Hey gang, we are on chapter 8.1 on metabolism and thermodynamics, and we are going to actually get into some reactions happening inside of cells this chapter, and we get into some pretty heavy topics on what drives everything that happens in our cells. But anyway, I wrote down the key terms from this section here on the left side to make sure that you understand these things. And I've got a picture here of an assembly line, so it looks like a Volkswagen Bug assembly line over here. And the reason I have this is for this first term, metabolic pathway here. Metabolic pathway inside of a cell is going to be a series of reactions that are linked together, taking a molecule and turning a molecule into a different molecule, doing a reaction to it to turn it into a different molecule again, and doing another reaction, another reaction, another reaction. And that's a metabolic pathway. In the case of this Volkswagen Bug here, you can see that the first step in our metabolic pathway, it looks like they have a chassis down here, and they're doing something to that, but there's something happening at this location, and we're going to call that location enzyme 1. I'll talk about enzymes in a moment. Then it's going to move from this location to a new spot, location 2, and we're going to say that's where enzyme 2 is. And a different thing happens there, and it's going to change our thing that we've assembled. It's going to add a body to it and doing another job, and it's going to move on down the assembly line step by step by step until we get our final product, whatever it is we happen to want. Metabolic pathways can either assemble something like this one, or they can take them apart, which would be kind of the reverse of this. All right? If I look in an organism and take every single reaction that happens inside that organism, that's going to be the metabolism of that organism, or if it's a cell, the metabolism of that cell. It's every reaction that's happening inside of there. Usually those are within metabolic pathways. Very seldom would a cell do a reaction without it leading to another reaction and then to another and another and so on. But those are metabolic pathways. These enzymes are basically just machines. They're actually proteins, but they're machines that are doing a specific role, causing a specific reaction, causing a specific reaction, and we call them a catalyst. The reason we call them a catalyst is something that makes a reaction happen faster. An example of that, I used to paint water towers, and the paint that we would put on these water towers had two parts, a part A and a part B, and the part B we actually called the catalyst. The part A had all the pigment and all the color that you wanted, and if you were to paint with just the part A, it would never ever dry. It would just sit there on the tank and never dry. But if you added the part B to it, it would immediately start to dry. So you actually had a couple hours you had to use up that paint once you added the catalyst to it, because it would cause the paint to start to dry. So it basically speeds up a reaction. These enzyme catalysts then, another little tidbit about them is they can be reused over and over and over and over again, kind of like this spot on the assembly line. It doesn't do one thing and then it's done. It is actually used over and over again. So last little note here. The pathways within metabolism, within the all of metabolism, we can basically either break things apart or put them together. If we break something apart, it's called a catabolic pathway, and if we put something together, it's called an anabolic pathway, pathway. The way that I remember the two of these, an anabolic pathway, if you ever remember reading or hearing about anabolic steroids, and that's what's people in Major League Baseball were getting busted for using anabolic steroids, human growth hormones, things like that, but they would build up muscle, and anabolic pathways build up molecules. That's how I remember that. So we'll leave it at that. What we're going to find is these catabolic and anabolic pathways, whether they happen or don't happen or things like that, it's all driven by some energy concepts. And so the next slide we're going to take a look at some energy concepts to explain all that.